Good afternoon everyone, thank you for joining me for this video. I am Mr. Ish. We are talking about a variation of the arctan antiderivative, the type of integral which would give you an arctan antiderivative. That type of integral has a slight variation to it, and we will be discussing that. This is one of those videos where you should watch the other arctan antiderivative video, the one right before this, first, then come to this, so you are more understanding of the procedures that you will see in this video. Very quickly, if you see anything like this, 1 over 1 plus x squared dx, you know you're thinking of an antiderivative such that if you did the derivative of this antiderivative, you'd come back to this and you'd be thinking of the arctan x. These are questions and variations based on these type of presentations. In the video right before this, you saw questions which were kind of like this, based on a template technique, and you would come to realize that the answers would always be of this form. So we were looking at questions that kind of looked like this: a squared plus x squared, or you can just say a plus x, such that you'd always have 1 over root a arctan x over root a plus c as the resulting type. So these are the type of questions we saw previously in the video. We want to look at questions of this form, but there will be a variety or a variation in this such that you can no longer apply this template over here and you have to do other procedures. The number one best way to handle this variation, the variation that will lead to a different type of an arctan antiderivative end result, is to actually look at examples and not talk too much about templates, because as we do these examples, I'll show you what the technique is. If you're seeing something like this in the denominator, you have to somehow convert this into this form: a squared into 1 plus u squared. If you can do that, you can actually come to the end result. The only way you can do that is by doing some manipulation over here, such that you can come to this. You want to be able to present a substitution for x, such that when you put it right here in place of x and you were to square it, you could come to this outcome. And let me show you. You know you need to have in this outcome a u come on the top, and you know there's a square sitting outside, because this x here represents everything in the box. Something should cancel out with this 4, and the only way we can cancel out something with a 4 if we were to square would be a 2. And the only way we can bring out a commonality here, a squared or a for that matter, is something which would be just a 1. And you could see this play out. So x here would be really u over 2. This square is just representing what you see over there. In these type of questions, you actually have to work backwards. You see how I'm starting from this, and now I'm going to work backwards, and I'm going to show you. Once we have x is equal to u over 2, you actually solve for u. U is equal to 2x. Once you go down this technique, now you know du is equal to 2 dx and dx is equal to du over 2. So the most important step of this type of question is this right here, the very first step, and then from here you have to work backwards to get these items, the u, the du, and this. And then this is what you substitute. You know dx is equal to du over 2, so your integral becomes du 1 over 2, this over 2 is 1 over 2, you have 1 plus 4x squared. X squared, this u value will come in at the very end. X squared is this u over 2 square. When you open this up, you'll see exactly how we'll end up at this step, and this is what we have to aim for. You'll have du over 1 plus 4u squared over 4, which if you simplify you get 1 over 2 du 1 plus u squared, and that's exactly what we're hoping for, 1 plus u squared. This a squared here is represented by a 1, an imaginary 1 in this case. Now you just do the antiderivative of this. You have 1 over 2 arctan u plus c, but what's u? And this is where this step comes right over here. 1 over 2 arctan u is 2x plus c, and the question is done. And you can see there's a stark difference between the type of answers we're seeing in the video right before this and the type of answers you're seeing here. But again, it's still an arctan antiderivative, but it's a variety, because here the variety is, in these type of questions, you're looking at a form which is something like dx over a squared or a plus bx squared. This introduction of a b is what creates that complexity. So this is our question number 2, integral dx divided by 3 plus 4x squared. I've plugged the denominator here on the side such that we can aim towards converting this into this type of an expression. And the best way to do that is to think and work backwards. You have to plug something here in place of x, which is affected by square, such that you could arrive at that by means of isolating, simplifying, and all of that. You know you have to bring a u here in the numerator, because when you do u square, you'll get that u square. You have to somehow cancel this 4. This is like your b term. Integral dx over a square plus bx square. Your b term is here 4. You have to somehow cancel this 4. If you put a 2 over here, 2 square will bring you a 4 and it'll cancel it out. And you have to be able to isolate a 3. A root 3 square will bring you that 3. Once you have this, you were to plug it in, you'd get to that. But we have to do something else first. If x is equal to root 3u divided by 2, then u is equal to 2x over root 3. You're working backwards. Then du is equal to 2 over root 3 dx. Then dx is equal to du root 3 over 2. Cross multiply. You'll need this for the very last step. You'll need du and dx for this next step. And of course x, you'll need that now. You write everything now in terms of du. You have a root 3 over 2. And here you have 3 plus 4 times x square, which is root 3u over 2 square. When you open this up, you'll arrive at something which looks like that. Root 3 over 2 du 3 plus 4 times 3u square over 4. Cancel these out and you have what you need. Root 3 over 2 du over 3 plus 3u square. And this is what I want and this is what I see right over here. You can isolate root 3 over 2. You have du, isolate 3, you have 1 plus u square. Bring this 3 right over here with this. You'll have root 3 over 6 integral du over 1 plus u square, which is easy. But before you actually do the antiderivative, let's simplify this. You can do rationalizing of the numerator. Root 3 times root 3 over 6 root 3. You'll have 3 over 6 root 3. 3 can cancel out with this. You get 1 over 2 root 3. So all of this expression simplifies to 1 over 2 root 3. 1 over 2 root 3 arctan u. But what was u? This is where this u comes into place. 2x over root 3 plus c, and you're done. So these type of questions require you to look at something which is like this type of template. Here you have a b value which complicates things, and you have to work backwards through the procedure. Always starting with finding the x, then you find u, then you find du and dx. So let's look at this question. Integral dx divided by 9 plus 7x squared. We're looking at equation of this form, where in the denominator you have a squared plus bx squared. The presence of that b, which in this case is a 7, creates a complexity, and our goal is always to look at the denominator and somehow convert it into this form. And we have to do that by thinking and working backwards. You have to plug something here in place of x such that you could get to that form. And you know you must bring a u here in the numerator, because after the square procedure will become a u square. You have to somehow cancel that 7. I can do that with a root 7 here in the denominator, and somehow I need to bring a 9 here in the numerator, and I can do that by bringing a 3. Because after this procedure, if you were to square this, you'll have 9u squared over 7, which when multiplying by 7 will get you to this part. And yeah, since x is equal to 3u over root 7, then u is equal to root 7 over 3x. This we'll need for the very end. Du is equal to root 7 over 3 dx, and then dx is equal to du 3 over root 7. All of these items. You have 3 divided by root 7 du over 9 plus 7 times x square. 3u over root 7 square. So next step, 3 divided by root 7, you'll have a du over 9 plus 7 times 9u square over 7. The 7's cancel out. You see I'm getting a 9 plus 9u square. You can isolate that 9. You'll have a du and 9 into 1 plus u square, and that's what I'm trying to get. This type of format. A squared parentheses 1 plus u squared, and I have it. I can bring the 9 right over here. I'll have 3 divided by 9 root 7. I'll have du over 1 plus u square. These 3 and 9's can be cancelled out and simplified. You'll have 1 over 3 root 7. And let's do our completion. Arctan u plus c. Our final answer is 1 over 3 root 7 arctan u, and u right here. This last step, it actually involves you putting the u to use. Root 7 over 3. 1 over 3 root 7 arctan root 7x over 3 plus c. So let's look at this question over here. We have integral dx divided by 2 plus 7x squared. Again, it's in the form a squared plus bx squared. the b value 7 over here creates the issues for us. Look at this denominator 2 plus 7 x squared and try to convert it into a squared into 1 plus u squared format. And we have to think and work backwards. We'll put some value here, x, in the box. This is represented by this x over here. You gotta bring a u into the picture, so we'll put a u over here. You have to somehow cancel the 7 in the numerator by this root 7 in the denominator because it'll get squared. And you gotta be able to isolate a 2, and you can do that by doing a root 2, because if you were to open this up, you'd get a 2u over 7. And x is equal to root 2u over root 7. U is equal to root 7 over root 2x. Du is equal to root 7 over root 2 dx. And dx is equal to root 2 divided by root 7 du. So we're basically looking and working backwards here. Root 2 divided by root 7 du over 2 plus 7 times x squared, which is root 2u over root 7 square. You have root 2 divided by root 7. Here you have a du over 2 plus 7 times 2u squared over 7. You see the 7's will cancel out. You'll have root 2 over root 7 and du into 2 parentheses 1 plus u squared, and this is what I've been aiming for, and that's what I've gotten. All made possible by this substitution right over here, or by this thinking backwards. Bring the 2 out right over here. You'll have a root 2 divided by 2 root 7, and then you have du over 1 plus u squared. You can probably simplify this. You'll have 1 over root 2 root 7, which is 1 over root 14, and then here you have arctan u plus c. But what's u? U is this root 7 over root 2x. You have 1 over root 14 arctan u root 7x over root 2 plus c. But we can present this answer in a better way by rationalizing the numerator. Let's rationalize it. Root 7x times root 7 divided by root 2 times root 7. I get a 7x over a root 14. That's what I'm going to really put over here. 7x divided by root 14. It's good to rationalize and make your answers seem a little more uniform. Arctan 7x over root 14 plus c. How is this uniform? Because I have a root 14 here and I have a root 14 here. So it makes it look and feel much better. I think we'll present one more question worked out and then we'll be done with this video. So this right here is our last question. Integral dx divided by 6 plus 5x squared. These type of questions are represented by this format. A squared plus bx squared in the denominator. The b item over here creates a complexity for us. These all lead to eventual arctan antiderivatives. And our goal is always to look at the denominator expression and convert it into that form. And you do that by working and thinking backwards. You have to find a substitution for an x that's such if you squared it and did your isolating and all of that, you'd end up with this. You gotta have that u in the numerator, and somehow you have to cancel this 5, and you can do that by root 5 because it'll get squared. You gotta bring a 6 in the numerator, and you can do that by root 6 here in the numerator. So the root 5 is in the denominator, root 6 is in the numerator. X is equal to root 6u over root 5. Solve for u. U is equal to root 5 over root 6x. Then du is equal to root 5 over root 6 dx, and dx is equal to root 6 divided by root 5 du. You have root 6 divided by root 5, and then you have du over 6 plus 5x squared, which will be root 6u over root 5 squared. Open things up. Root 5 du over 6 plus 5, 6u squared over 5. These 5's will cancel out. You'll have root 6 over here, root 5, and then du divided by 6 plus 6u squared. You can isolate 6 and you can make this into 6 parentheses 1 plus u squared, and we see what we want. You can bring the 6 right out over here. You'll have root 6 divided by 6 root 5. You'll have integral du over 1 plus u squared. Once you've come to this 1 plus u squared, you know you're good. But you can simplify this out. You can simplify this and make this into root 6. But this root 6 times root 5 can give you a root 30. So let's just do that. 1 over root 30. Then you'll have arctan u. What's u? Right over here. Root 5x divided by root 6 plus c. But we have to simplify this to make it look like a uniform answer. Rationalize the numerator. You get a 5x divided by root 30, and that can substitute for right over here. Our final answer is 1 over root 30 arctan 5x divided by root 30 plus c. You can present this as a final answer, but you see it doesn't look uniform. You have a root 30, root 6, but when you rationalize it, you have root 30, root 30, and this right here is a better answer. So in these type of questions, keep in mind you're looking at something like this in the denominator, and you have to start in this procedure such that you can convert this type of expression into that. And you do it by first finding an x value, then from the x value, you'll find the u value, then you'll do the du, then you'll do the dx, then you'll do your normal progression of these question types. Thank you for watching. Have a nice day.